Once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamoto. And today I want to conclude topic number 7 of Pure Mathematics 1 with example 12, which is on page 142. And it's telling us in the diagram, AB is the diameter of a circle of radius r. AB is the diameter of a circle of radius r. And if it is the diameter, then it must be passing through the center. So O is the center of the circle. And angle BOC is theta. Angle BOC is theta. Theta radians. Given that the area of triangle AOC, given that the area of triangle AOC, this triangle, is 3 times that of the shaded segment. This is the shaded segment, 3 times that of the shaded segment. Show that 3 theta minus 4 sine theta is equals to 0. That is the question. And of course, we need to bring on board both the area of the segment and the area of the triangle. And let me start with the area of the segment because this is where we have the angle. Area of segment, of shaded segment, in the previous example, we have understood this one to be equals to a half r squared theta minus sine theta. That is the area of the shaded segment. That one aside, let us now talk about area of triangle AOC. This triangle is given by a half r squared sine, let's call this angle alpha, sine alpha. But there is a special relationship between alpha and theta because alpha is equals to 180, which is pi minus theta. So, of course, because the angles on a straight line is 180 or rather pi, so the area of that particular triangle is a half r squared sine pi minus theta, because we do not have an angle called alpha, but we have theta, so we must be able to present it that way. Now, I would want us to just for a moment remember the following, that in a quadrant like this, all science teachers complaining, in this quadrant when we have theta, all trigonometric ratios are positive here. If you go to the second quadrant and this is theta, you realize that this is the angle we are talking about. This angle is now the alpha. And that alpha, because it's 180 or rather pi minus theta. And according to this, the sine of pi minus theta is the same as the sine of theta, because theta is the angle between the horizontal x-axis and the line of angle. This will be explained further in C2. But let's say sine pi minus theta is the same as sine theta. We shall explain this further. So therefore, the area of the triangle AOC now becomes a half r squared sine theta is equals to 3 times a half r squared theta minus sine theta. That means the area of the triangle is 3 times the area of the shaded segment. It goes without saying that a half r squared cancels out, so we remain with a statement that reads like the sine of theta is 3 theta minus sine theta. Opening this bracket, we have the sine of theta is equals to 3 theta minus 3 sine theta. Look, we are supposed to show that 3 theta is 4 to show that 3 theta minus 4 sine theta is equals to 0. And all what we need to do, we just need to understand one fact, whereby this sine theta now crosses over to be subtracted. And therefore, we have something that talks about 3 theta minus 4 sine theta is equals to 0. And at that point, then, we have proved what we were to show, therefore, hence shown. I know there could be a challenge understanding that sine pi minus theta is equals to sine theta, but that should not be a problem. We are coming to that topic, further trigonometric identities and ratios. So, but to understand, all trigonometric ratios in the first quadrant are positive and sine is positive. So, and the angle between the horizontal x-axis and angle line is theta, which is also reflected here. So that makes a lot of sense, but it will further be elaborated as we move forward. So that is it. And please again visit my YouTube channel, Pearson at Excel International Maths, and let us subscribe and share widely.